Welcome to the DIY Honda Garage channel. DTC P2649 indicates a problem related to the rocker arm oil control solenoid A, located on bank 1 of the engine. This solenoid plays a crucial role in controlling the flow of oil to the rocker arms, which directly affects the engine's valve timing and performance. The circuit is detected to have high voltage, suggesting an electrical issue rather than a mechanical failure. Before proceeding with repairs, it's vital to have the details outlined in the diagnostic report on hand. This presentation will guide you through problem identification, troubleshooting steps, and potential resolutions for the DTC. Instructors may find this guide useful for training sessions or workshops focused on Honda vehicle maintenance and troubleshooting. DTC P2649 signifies that there is a high voltage presence in the rocker arm oil control solenoid A circuit for bank 1. This solenoid is an electromechanical device that regulates oil flow to the rocker arms, facilitating variable valve timing. By controlling the oil, it allows for enhanced engine performance and efficiency. In the Honda Pilot, this solenoid is typically located on the cylinder head of bank 1, which means it's situated adjacent to the timing chain or belt area. The electrical circuit condition leads to poor valve operation and may complicate engine performance. Monitoring the solenoid's function is essential for maintaining optimal engine operation, as it plays a fundamental role in the variable valve timing mechanism, known as VTEC in Honda terminology. There are several possible causes for the DTC P2649 reading. First, a blown fuse can disrupt the circuit, leading to high voltage readings. The specific fuse to check is C7, located in the under-dash fuse/relay box with a 15 amp rating. If the fuse is compromised, it will need replacement before further diagnosis. Secondly, the rocker arm oil control solenoid itself could be faulty, requiring an internal resistance check to determine its operational integrity. Lastly, wiring issues such as short circuits or open wires can also be culprits. The wiring between the rocker arm solenoid and the powertrain control module, PCM, requires thorough inspection for continuity and integrity to address any potential electrical failures. Drivers may notice several symptoms associated with DTC P2649. One of the most common signs is poor engine performance, resulting from the solenoid's inability to adequately control oil flow to the rocker arms. This can lead to decreased power and efficiency, especially under load or during acceleration. Additionally, the check engine light, CEL, is likely to illuminate, alerting the driver to a malfunction within the engine control systems. Another observable symptom may be increased oil consumption, as the malfunctioning solenoid disrupts normal oil regulation, potentially leading to oil leaks or excess usage. These symptoms can significantly affect overall vehicle performance, and they indicate that immediate diagnostics and repair are necessary. The first step in troubleshooting DTC P2649 involves turning the vehicle ignition to the on mode. This allows the onboard diagnostics to initialize and be evaluated. Next, use the Honda Diagnostic System, HDS, to check for any confirmed or pending diagnostic trouble codes, DTCs. This step is critical, as it ensures that the technician has the latest information regarding any current issues with the vehicle's electronic systems. If other related codes, such as P0102 or P2659, are present, they may indicate interconnected problems that need to be addressed. Assessing all DTCs simultaneously will provide a broader perspective on the vehicle's condition and directs the technician on how to proceed effectively. The second troubleshooting step is particularly important for identifying electrical issues. First, turn the vehicle to the off or lock mode to ensure safety while inspecting the fuse. Locate fuse number C7, a 15A fuse situated in the under-dash fuse relay box. This fuse is significant as it protects the circuits related to the rocker arm oil control solenoid. Inspect the fuse visually and conduct a continuity test to ascertain if it is intact. If the fuse is blown, replacing it is essential, but one must proceed cautiously to avoid repeating the failure. If the new fuse blows again, this indicates a deeper issue within the electrical circuits, specifically concerning the circuit paths between the solenoid, the engine control unit, or the EGR valve. The third step in the troubleshooting process requires turning the vehicle ignition to the on mode once again. After initializing the systems, the technician must clear the DTCs using the HDS. This action resets the DTCs, enabling an evaluation of whether the issue persists. Following this, start the engine and allow it to idle while maintaining an RPM of 3000 without load until the radiator fan activates. This procedure ensures that the vehicle reaches operating conditions that may promote the reappearance of any existing faults. After this procedure is completed, check for pending or confirmed DTCs again. If DTC P2649 returns, this indicates a persistent problem, leading to more in-depth diagnostics. For Step 4, power down the vehicle by turning it to the off or lock mode. Disconnect the 2P connector from the rocker arm oil control solenoid A, located on bank 1. This step is essential for safe testing without electrical interference. Once disconnected, measure the resistance across the solenoid between test points 1 and 2. At room temperature, the expected resistance should range from 14 to 30 ohms. If the readings are outside of this threshold, it suggests an internal failure within the solenoid, necessitating its replacement. Ensuring these readings are accurate is vital for diagnosing solenoid functionality, as a healthy solenoid directly impacts both performance and efficiency. When moving on to troubleshooting Step 5, the focus shifts to electrical integrity. Again, make sure the vehicle is turned to the off or lock mode and the rocker arm oil control solenoid A 2P connector remains disconnected. The next task is to check for continuity between test points 1 and 2, ensuring there's a solid connection between the solenoid and grounded body points. Conducting a continuity test serves to identify any open circuits or faults in the wiring that could be causing the DTC. If continuity exists, it signifies that the VTSB1 PG line is functioning correctly. Should there be no continuity, this points to an open circuit within the wiring, indicating the need for repairs or replacements in that area. In the sixth step, it is crucial to troubleshoot the VTSB1 line more thoroughly. First, jump the SCS service check signal line using the HDS and wait for more than 1 minute. This step enables the diagnostic mode to capture any fault indicators while the system is under observation. After awaiting the correct duration, disconnect the PCM connector C, which has a total of 51 pins. The next step is to test for continuity between test points 1 and 2. These test points involve the disconnected wires from the rocker arm solenoid and the PCM. Like before, continuity indicates that VTSB1 is functional. However, absence of continuity suggests issues in the wiring that link the PCM and the rocker arm oil control solenoid A, necessitating repairs along that pathway, and could potentially indicate PCM issues if nothing else is wrong. Final repair verification is paramount to ensuring that all necessary fixes have been properly implemented following diagnostic troubleshooting. Start by confirming that all repairs conducted on the rocker arm oil control solenoid A and associated circuits are sound. After verifications, turn the ignition to the on position, and use the Honda Diagnostic System, HDS, to recheck for any remaining DTCs. This step helps verify that the previous issues concerning DTC P2649 have been resolved. If new or the same DTCs reappear, additional diagnostics may be required, indicating that further underlying issues could exist, requiring you to retrace troubleshooting steps or inspect additional components. Adequate verification safeguards against future failures related to the solenoid or associated circuits. Preventive maintenance is crucial for avoiding future DTCs such as P2649. One critical practice is to perform regular oil changes according to the manufacturer's schedule. Fresh oil keeps the internal mechanics properly lubricated, ensuring optimal operation of the rocker arm oil control solenoid and associated components. Additionally, routine inspections of the solenoid wiring and connectors can prevent issues related to poor connectivity or corrosion. Monthly checks can help catch early signs of wear, loose connections, or frays before they culminate in circuit failures. Such proactive practices enhance overall engine performance and prolong vehicle lifespan, while reducing the likelihood of subsequent expensive repairs. In conclusion, addressing DTC P2649 boils down to understanding its implications on engine performance and ensuring thorough diagnostic procedures are followed. Effective troubleshooting requires you to methodically assess each step, from electrical checks through to solenoid assessments, to identify the root cause of issues. Each troubleshooting phase plays an instrumental role in discovering faults that could lead to significant performance degradation. Engaging in preventive measures such as regular oil changes and vigilant inspections will help avert similar issues in the future. By familiarizing yourself with both the fault definitions and troubleshooting processes, you enhance your toolkit for proper vehicle maintenance, ultimately improving the Honda Pilot's reliability and performance. Please like and subscribe to the channel. See you next time.